Okay, it's 9 o'clock. Okay, I will get started. Let's see. Last time we talked about this lecture 2, the data compression. Okay, it's a unit 2, data and information. And we finished the so-called text compression, lossless. Okay, lossless compression. And we talk about the result of the lossy compression for JPEG. Okay, so we go through that. We had the so-called we go into the compressions scheme, encoder and decoder. Okay, that's what we did, and we go through the LGW compression. Okay, LGW compression that we play a video, right? And it actually tell you how the compression can be done without sending the corpus. Okay, without sending the corpus. So that actually is in the layer 6 presentation layer. Okay, so there are 7 layer architecture in internet. Okay, later we are going to talk about internet. We will talk about this structure. So layer 7 is browsers. Okay, so whenever you browse your internet, you have the Google Chrome. Okay, you have a browser, and browser using HTTP protocol. And then in layer 6, you have presentation layer. In that presentation layer, data compression will happen over there. Okay, data compression is one of the mission in that layer. But today we are not talking about internet, so I'm not going to emphasize it too much. Okay, and we emphasize that, but we did not. We finished up to there, and then image compression. We haven't started the image compression, the lossy compression algorithm yet. Okay, so today we will get started with this portion for lossy compression, and for so here we would explain the difference between lossy and lossless compression. Okay, identify common computer file type and how they are compressed. Okay, so this is I try to avoid too much technical detail. Okay, so lossless compression is a data compression algorithm that allows original data to be perfectly reconstructed. So key point is you are lossless. You should be able to be reconstructed from the compressed data. Okay, that is called lossless. Lossy actually is you will lose some details. So usually for JPEG, okay, you actually may lose some detail. So usually lossy compression ratio should be 2 to 13 times. Okay, that's a typical number. Lossless usually is 1 to 3 times. Okay, so usually lossy compression is compression ratio better, but it will actually introduce the error. Okay, you introduce a little bit of the error. Okay, so that's the difference between lossy and lossless compression. Okay, today we are going to look into the image file format and then see how the lossy compression will be done. Okay, so basically, no matter, okay, can you mute your micro? Yes, thank you. So no matter lossy or lossless compression, actually you usually look at the pattern in your file. Okay, you look at your repeated pattern in your file so that you can compress the data. Okay, usually you need to look at some pattern. So for now, actually that's the lossy portion. Okay, text compression. Then let's see. File format is okay, and let's see. This one, let's actually already jump into. Before we jump into the Huffman encoding, let's actually go to the JPEG first. Okay, so JPEG. So JPEG is the so-called joint picture expert group. Okay, JPEG's original name is called joint picture expert group. Okay, this was developed somewhere around 1990s. Okay, early 1990s. So somewhere around when I was in the college or PhD program, we get started to do this. Okay, so one of my master programs project is working on a full JPEG standard to write the C code to implement it. Okay, so this one I do hand implement JPEG before. So that is called JPEG. So JPEG, what is the JPEG? Okay, so JPEG's main purpose is to compress your code for picture. Okay, so for picture. So picture, how can we do compression? We actually have a picture. And how can we actually compress the picture? So each pixel you have RGB, red, green, and blue color, right? You made of the red, green, and blue color. And how do you compress your data from here to here? Okay, so how you make the decision of doing that, that's the key point, okay? So you do not lose too much information. So there is a basic fundamental idea that's called something we call it spatial frequency, okay? You must know about what is spatial frequency, okay? Spatial frequency. Spatial frequency is a frequency in space, okay, in space. But before we talk about spatial frequency, let's talk about the temporal frequency, okay? Temporal frequency, okay? Here it should be RAL. Temporal frequency, okay? So temporal frequency is a frequency in time, okay, in time. So we call it temporal frequency. So what is temporal frequency? Temporal frequency is that, okay, originally our signal may be like this, okay? Maybe like this. We have a square wave, right? We have square wave, but this square wave can be represented by the harmonic of the wave, okay? So we actually represent it like this, okay? So that's called first harmonic, okay? First harmonic. And then we can actually introduce the second harmonic. Okay, so second harmonic would be something like this. Okay, something like this. Okay, whatever. So the black one actually is the time domain signal. Okay, time domain signal. And the red one and green one are the frequency domain signal. So here, basically your original signal, let's assume that this one is called f of x, okay, f of t, okay, time, f of t, a function in time, okay. Then this one, f of t, should be, can be represented by a red signal that would be a sine 2 pi ft, okay, that's a sinusoidal signal. So that you have the f1, okay, first frequency, and then plus the green frequency, okay. So you have a2 sine, okay, 2 pi f2t, okay, the second frequency. So by doing that, actually your time domain signal can be represented in frequency domain. So your frequency domain by f1 and f2, and then your amplitude can be put over there. Okay, that's actually your a1, and your a2 may be smaller. Okay, and then another small. Okay, so you have multiple frequencies. So you convert your time domain signal into frequency domain. Okay, this is usually we call it transform. Okay, if you study the math, multivariable math, you may learn the Laplace transform, okay, or Fourier transform. Okay, so right here I don't want to touch that deep. Okay, you just know that if you learn your multivariable or differential equation or physics, okay, that will help you to learn this theory a lot, okay? But we don't jump to there. The basic idea is very simply your original time domain signal can be converted into a series of different frequency, okay, of the sinusoidal signals, okay. So this signal can be put into this domain. Okay, that's called time domain. Time domain frequency. Okay, let's look into the spatial domain. Okay, so in your image, in your picture, you have something like that as well. Okay, we call it spatial, but it's two-dimensional. So it's two-dimensional. So actually, you should see that. Okay, the DC turn is over here. You have a DC turn. Okay, DC turn is average. Okay, average we call it DC turn. Okay, this one is average. So what is DC turn? DC turn is when you have the sinusoidal signal. Okay, when you have the square signal. Okay, when you have a square signal. Okay, there is an average. Okay, the average is called DC turn. Okay, DC. And the sine wave, we sometimes call it AC, right? Alternative current, direct current, right? So this DC means the average. AC means that you have sine wave. Okay, so sine wave is AC electricity. Okay, so that is those kind of term. Okay, whatever. These are not important. Important thing is this one is low frequency. Okay. So higher frequency, your sinusoidal signal will be faster. Okay, sensing in the two-dimensional domain is the same thing. Okay, your two-dimensional thing is same thing. So here your DC turn is average. So it's just this. Here you have higher frequency in the corner here. So frequency grow in this way. Frequency go in this way. So your original picture of 8x8 block, okay, originally you have 8x8 block, you will convert it to such kind of the frequency domain data. Okay, that's using the DCT, discrete cosine transform to do that. Okay, so your discrete cosine transform is used to convert it. Okay, anyway, so here that's given a picture like this, and I take a block of 8x8. Okay, here I have a block 8x8, and after DCT transform, I get some data on the right side. Okay, I get the data on the right side. So this is the data I get from the right side, and it actually is a transform. Originally is a picture, and then converted to here. As you can see, the data actually DC turn is bigger. Okay, and these corners are smaller. So basically, if we cut somewhere here, this whole thing I don't need to transmit. Okay. So then I only need to transmit this corner. So if originally I have 8x8 64 data, 64 pixel data, and then if I just transmit a component in frequency domain, then I will have a compression ratio of 64/8. Then I will compress the data by 8 times. Okay, by 8 times. And I will lose some data because I truncate this corner out. Okay, so I lose about some information. So that's the key idea. Okay, so here I have some image like this. Okay, these are the gray label signal 139, 144, 149, whatever. This whole thing using DCT, and it compressed to this format. Okay, then actually I just do quantization. So I actually let's cut some part of it. So let's cut this portion. This portion are smaller. You see 0.4, 0.4, 0.2, okay, 1.5. These are smaller number. DC turn get more data. So DC turn, you see the DC turn get 235. Okay, so if you cut somewhere from here, this data over here actually are almost a very small number compared to the time domain. Time domain actually, I'm sorry, not time domain, spatial domain. Spatial domain, everything are almost the same. Okay, almost the same. So by doing this, you can do data compression. So that's called DCT transform. Okay, so basically your original signal being if it's DC turn is taking the average. Okay, it's taking the average. So it's happening on this corner 0, 0. Okay. X dimension 0, okay, Y dimension 0, okay, frequency domain. We are talking about frequency domain, okay, and then 1 is such a frequency, okay, 2 is 2 sinusoidal wave, okay. 3 actually is 3 sinusoidal wave, okay? And here you may have many, okay? Many is up, down, okay? And this corner is actually everyone alternative. So this one higher frequency. So that's the theory, okay? And we do not intend to teach you the theory, but basically your DCT transform is like this. And your DC turn happen on 0, 0, and you just zigzag in to transmit about 8 component, 9 component of it. After that, everything truncated. We don't transmit the portion, okay? And we just transmit this small portion. At the receiver side, we recover it, okay? At the receiver side, we recover it. So basically, we do DCT, we do quantization, quantizer, and then we do entropy encoding. Then we get our JPEG. So by this way, we get our JPEG. Okay, by this way, we get our JPEG. Okay, by this way, we get our JPEG. And we transmit the JPEG signal to the other side. Okay, so the quantization algorithm is called Huffman encoding. Okay, here is called arithmetic Huffman encoding. Okay, but don't get scared. Okay, here you have red, green, blue, 3 color. They will all be transformed by the discrete cosine transform. Okay, and they will all be sent by a ratio of maybe 1 to 8 by quantization. And the Huffman encoding will compress another degree of 1 to 3 compression. Okay, another degree of 1 to 3 compression in Huffman encoding. So totally, you get 8 and maybe plus 3 or 8 times 3 plus 5 times of the compression ratio. You get from 2 to 13 compression ratio. Okay. From the DCT, there's a compression ratio about 8. From Huffman encoding, that's maybe 1 to 3, sometimes beta maybe up to 5. Okay, so that's the different compression. But anyway, that's the JPEG compression is done in this way. Okay, that's JPEG compression is done in this way. Let's go back to the Huffman encoding. Okay, Huffman encoding. So Huffman encoding is also called entropy encoding. Okay, using the entropy in your information to do compression. Okay, and this one is a very beginning Shannon theory to do this. Okay, but it's very simple. Okay, it's very simple. So basically, originally, if we have A, B, C, D, E, F, G, whatever, you need to transmit by 8 bit, right? You need to transmit by 8 bit. Now, if we calculate the frequency and we send E, E actually is more frequently seen, right? So we transmit by 0, 0, 0. Then E, we need 3 bit. A, 0, 1, 0. So A actually also 3 bit. Okay. So like this one, N will be 0, 0, 1, 0. So this one 4 bit. Okay. And all we send 5 bit. So by the frequency, the more frequently seen data we transmit in shorter way. The less frequently seen data we show, we actually send by longer bits. By that way, our total number of bits transmit for the data will be smaller. So this one is called Huffman encoding. Huffman encoding will also reduce the compression by 2 or 3. Okay, so this one is called Huffman encoding. So basically, JPEG consists of the DCT and the entropy encoding, the Huffman encoding. Okay, so this one the ratio 8, this one the ratio about 3. You send out the compression data, you recover it in the receiver, and then do inverse. This I is inverse DCT, you get your original data back. Okay, so during the process, you lose some quality. Yes, you lose some quality, but you can achieve a compression ratio of about 2 to 13. Okay, that's the theory. Okay, so this one is JPEG. Okay, we not intended to teach you the technical detail, but next one we quickly go into the MPEG. Okay, so MPEG is motion picture or whatever expert group. Again, this one later about 95 we started to look into the MPEG 2. Okay, so basically MPEG 1 is not that popular. MPEG 2 is more popular. That's around 95. So at this time, I was in PhD program, and I do have work on some project in this MPEG-2. Okay, this one is around 95. So at that time, we tried to achieve a compression ratio of 100 for video. Okay, 100 for video. Okay, 100 for video, and I got my PhD from USC, and if you look at the USC's Professor J. Cole, Professor J. Cole, okay, J. Cole, okay, this one. He actually won some IEEE medal for this. He's an inventor and the early pioneer in this MPEG group. Okay, so whatever, if you are interested, you can read his information. Professor J. Cole. And at that time, they tried to achieve a compression ratio of 100. Okay, of 100, whatever. That actually initially was MPEG-1, and then MPEG-2, and then MPEG-4. MPEG-4 used to compress the mobile video. That's before 2000. Okay, and after that we almost have similar scene until now. Okay, until now. So that's that. Now let's look into the MPEG. Okay, so let's look into the MPEG. MPEG's main purpose is to compress your video so you can transmit data through the streaming, or you can use the data go through your iPhone. Okay, go through your iPhone. So nowadays we can do Zoom, we can do video conferencing, we can make a video phone call just because of the MPEG. Without MPEG, we cannot do it. Okay, without MPEG, we cannot do it. So here, you need to have a video compression, and we calculate the data rate. Okay, so if you want to transmit this 2 megapixel image, okay, for 30 frames per second using 8-bit scheme, then you will need to have 1.5 gigabit per second data rate. Okay, so nowadays our Wi-Fi usually is actually just around 100 megabit per second. So there's no way that you can transmit that data through Wi-Fi. Okay, impossible. Okay, impossible. So by doing that, you need to have certain compression ratio. So this one, okay, 1.5 giga, and this one you cannot transmit the data in the full capacity. So let's assume that you only take 15 megabit per second that you can transmit. Then you need to have a compression ratio of what, 100 to support it. So that's why people come out with the idea that, hey, you roughly need to have a compression ratio 100 in order to make the Wi-Fi be able to carry your video signal. Okay, and why recently 5G is so important? 5G is important because that originally our 4G can only carry lower data rate. So your cell phone can only send smaller screen to you, right? If you want to send the real big frame image, your image quality would be sacrificed, okay? So the same thing, we want to actually achieve higher compression ratio, okay? So anyway, this one is for the video, the reason why we need to have video compression. So let's jump a little bit faster, okay? So to study the video compression, you want to know about the temporal correlation. Okay, what is temporal correlation? So let's assume that you have friend here and friend here, okay? Your car is moving from here to here. So the background, no change. So you only need to look at the motion portion. Who is moving, right? You only need to look at who is moving. So only the car is moving. So that's actually called temporal correlation. And sometimes we also call it motion estimation. Okay, so you need to find out the difference between the frame. So we need to predict some frame using some other frame. Okay, so because of that, MPEG here, originally, if you try to send out this video, okay, so your video, like this one, keep moving, and this guy actually not moving, right? So your image like that. So here we do not transmit the whole thing. So we do not do JPEG on this one, JPEG on this one. That's a full image compression, right? It takes longer time, so we do not do that. We just send out this one and this one, full image. Something in the middle, we do prediction. Okay, we do prediction, so p-frame. So this one called I-frame, full compression called I-frame. And then we have p-frame and b-frame. B-frame is interpolated by 2 frames from left and right, something before it and something after it. We call it b-frame. If you predict it from a full frame, you call p-frame. But anyway, you have I-frame, p-frame, b-frame. But you just transmit something that actually has changed. By doing this, you can reduce the video a lot. Okay, so basically you are sending some full image, some of the partial movement image. That's what you need. Okay, and you have a frame sequence, so you actually have full compression on here and here. Okay, so if we achieve that, right here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if it really works with some overhead, this scheme with every 12 frame to have one full JPEG frame, then we can achieve some compression ratio of maybe greater than 10, right? And JPEG by itself has compression ratio of 2 to 13. By these, we almost achieve 100. Okay, that's a goal. That's a goal we try to achieve for MPEG. Okay, for MPEG. So basically, that's the goal for us to achieve MPEG. Okay, so that's the goal. And okay, we don't go into too much detail for here. Okay, because these are too technical. But the key idea is that your new picture is like this. Your previous picture is like this. We can calculate the difference. Okay, later you use the difference and previous frame, you can recover your picture. Okay, so that's the so we can just send out a previous picture and the difference picture. We should be able to recover the new picture. Okay, so that's the idea of motion estimation and doing video compression. And here, because we are in review, so I cannot go too long on this. Okay, so basically, MPEG is still a lossy compression. Okay, and it's compression not only using the JPEG, but also the inter-frame correlation. Okay, we also look into there. Okay, so you will have a quantization error. Yes, you will have quantization error. So here, this one is a full MPEG frame. Okay, MPEG frame. And MPEG frame, there's an MPEG 2. Okay, MPEG 2. There's an MPEG 2 TS. Okay, MPEG 2 TS. MPEG 2 TS is used in video conferencing. So Zoom is using this one. Okay, MPEG 2 TS. So what we are doing right now actually is using MPEG 2. Okay, whatever. Anyway, that's actually for the so-called video compression. Okay. Now we are moving down to the next topic. Okay, we are moving on to the next topic. Now we are moving on to the next topic. Let me bring up the next lecture. Okay. This one is called information. Okay, information. Okay, so right here, we talk about data representation in binary, quantization, and analog digital signal, right? We talk about information compression. So today we move on to lecture 3, information. So information, we look into the overview of data science, okay, and big data, data cleansing, data processing, data visualization, data model, database, okay, these different data science terms, okay. So big data is a big deal right now, okay, both in the field of computer science and broader field and industry, okay. So this one is very important, and we have big data, and big data is affecting our life, okay. So we talked about the raw data before. This chart I showed you before, right? When we started data, I showed you this one before. So you have raw world, and you collect the raw data from there, and you process the data, and then you clean your data, right? Clean data because your original data may have error, may have empty space, may have something that some people type it in the wrong way. So you need to clean the data. After you clean the data, you actually send to for data analysis. And your data analysis, you may store it into database. And you use your past historical data to learn some model. Then it becomes machine learning. Okay, it becomes machine learning. So based on your data analysis and machine learning, you can build your data product. Okay, and you can show it for people and providing report and making decision. Okay, making decision. Okay, so say that actually is the goal. Is a goal for data science. Okay, from raw data to some data product. Okay, from data for people to make decision. So that's actually is an overview of the data science. Okay, so that's it's actually an overview of the data science. So here that's actually look into directly jump into one example. Okay, one example. So let's directly jump into this one called Moore's law. Okay, Moore's law. Gordon Moore is a person in Intel. Okay, so he said that every 2 years, okay, every 2 years, the computing power and capacity double every 2 years. Okay, double every 2 years. So this Moore's law you must learn. Okay, you must know about this Moore's law. Double every 2 years. Okay, so what does this mean? This actually means that he's with Intel. He's a person with Intel. He's an American businessman, engineer, and co-founder of the Intel company. Okay, so his prediction is like, okay, our semiconductor transistor. Okay, I talked about this before when we work on the binary. Okay, this one is one transistor. Okay, one transistor. So every generation of the transistor is actually shrinking size wise. Okay, so one dimension, if original is 10, okay, so here if after one dimension one time it will be shrinking by a ratio of square root 2, okay, in one dimension. So for example, if my current generation, if a current generation of semiconductor actually the channel width is actually, let's assume that right now it actually is 100 nanometer, right? In the channel of the transistor. Next generation, it will be 100 divided by square root 2. Okay, this one is roughly 1.414. Okay, so that's roughly drop from 10 to 7. Okay, roughly. This is estimated. Okay, so one way you drop by square root 2, okay, and two way in 2 dimension, it actually what? You will get 2 times, okay, in area. Area will drop by half, okay. So that's what he said. If originally one transistor, you take this much area, next generation of the transistor just take half of the space. And next generation take only 1/4 of the space. Next generation, you take only 1/8 of the space. Keep doing that, okay? So that's the rule he's predicted. So the same CPU, okay, so same CPU, okay, the same CPU. This generation of the CPU, if we take this much, right, Intel, let's assume this one's i7, okay. Next generation, if you had a semiconductor shrinking by square root of 2 in one way, okay, square root of 2 reduction, okay, in the area. So the original i7 next generation process, it will be this small. Next one, it actually only 1/4. And keep shrinking, keep shrinking. So if this happens every 2 years, right, then every 2 years, your computing power will double. That's what he said. That's the so-called Moore law that he said, okay? That's the so-called Moore law that he said, that every 2 years, the semiconductor will double, okay, will double, okay? And this one has been so interesting that, okay, in the year 95, okay, in the year 1995, when I was in PhD program, I'm working on AI. At that time, we are working on the so-called 5-micron technology, 1995, HP process, okay, 5-micron. In this year, 2022, okay, right now TSMC is 5 nanometer. So what? It's a reduction of 1,000. So originally it is this big. Now it's only 1,000 times one way. So this one square, it will be 1 million times computing power over this many years. We dropped from 1 micron, 5 micron to 5 nanometer. We gain almost 1 million times computing power. So at that time, when I do neural AI design, I build 10 neuron on IC. Right now, you get 10 million neuron on IC. So that's why after 2015, AI become possible. Not because people improve the software, but because people improve the hardware, okay? Because people improve the hardware, so basically nowadays, it becomes possible for those kind of high performance computing on PC to be available. So this one is a so-called Moore law, okay, Moore law. And he observed the trend, okay, and make product like this, okay, make product like this. And every year, the semiconductor sales and the size of the computing keep moving up. So we can predict that what would happen next year, what would happen 3 years later, okay? So this year, 2022, we already will see TSMC shipping 3-micron technology. 2025, TSMC will ship 2-micron technology, okay? So the computing power keep growing, and the computing power will double over another 3 years. It will double, okay? It will double another 3 years. So after it double, what should we do? What should we do with our iPhone? What should we do with our computer? Okay, that's using the data trending to make decision. Okay, that's using the trending to make decision. So something we cannot do like 10 years ago because of this semiconductor improvement. We do see the big change. We do see the big change. So that's the purpose of doing the data science. Okay, that's the purpose of doing data science. You collect the data, you analyze, you build a model, and you visualize it, and you show people, hey, this is the trend of your semiconductor computing power. Every 2 years, the processing power will double. And originally, you build a small PC here. Now, you are going to add more and more function to it. So what kind of computing we can do over there? So that's the kind of question that Intel is trying to answer, NVIDIA is trying to answer, AMD is trying to answer. What is the high performance computing of tomorrow so that we can change our world? Okay, so now people say maybe meta-universe, right? Okay, meta-universe. Meta-universe maybe what needed that kind of computing power 10 year, 5 year, 10 years later, right? So it's kind of making prediction to see what will happen and how our business should move. in order to catch up the trend. Okay, so the whole data science is starting this. Okay, starting this, collecting data, cleansing the data, analyze the data, store the data. Okay, using machine learning model to find a trend. Okay, predicting the future, making decision, make impact on our society. Is that okay? Hello, hear me? Is that okay? Hi, Emma. Emma Zhong, is that okay?
Yeah.
So that's the purpose of why we study data science. And okay, now I'm going to talk about the relationship of data science and computer science. Okay, I'm going to talk about it. Now let's actually look at UC Berkeley. Okay, UC Berkeley. UC Berkeley. Here we have the so-called school. Actually, it's called division. Okay, division of data. Okay, computing. Okay, and the society. What it is? Okay, that's what it is. This one is called Berkeley Computing, Data Science, and Society. Okay, this is a new division. Okay, this one is a new division, but in the future, you become a school. Okay, you become a school, become a college. Okay, so let's see what are they. Okay, you do see the Berkeley Data Science Institute, Computational Biology, Data Science Program, ECS, so also CS, okay, ECS means that CS is inside the ECS, School of Information, Statistics. So everything here, they are putting into a new organization called CDSS, okay, Computing Data Science and the Society, CDSS, okay, this is going to be a new college in Berkeley. Okay, this is going to be a new college in Berkeley. Let me make it smaller. Okay. Okay, here is, you will see that actually division of this is moving closer to becoming a college. So Berkeley actually is trying to moving in that way. Okay, so if you want to study the computer science, okay, nowadays you have, say, math department, right? And then you have applied math, okay? And you may have statistics, okay? You may have data science, okay? You may have computer science, right? Computer science. You may have the so-called ECS, right? And finally, there's another one called MET, okay? And on top of this, you also may see something like business school. And there's also another one called physics, okay? So what this chart means, like, okay, if you are very specialized, you can only specialize in math. So this way is more specialized major. So this one more specialized. Okay, and this way is more broad. Okay, more broad. Okay, so math, statistics, data science, computer, ECS, MET. So this one bigger than that, 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 this one bigger than that. Okay, in terms of domain, ECS including EE and CS, CS including programming and mathematics, and the programming portion take out the hardware programming, just keep the Python and statistics, it becomes data science. You take out the programming, just the statistics, it becomes applied math or statistics. You take out the applied portion, you just study the pure math, it becomes math department. So left side is very broad, right side is very specialized, okay? So data science need the people of different kind in this spectrum, okay? People of different kind in this spectrum, and that's why Berkeley is trying to create a new college, okay, the new college of this one called Computing, Data Science, and Society. And you will include these different school and program into there. Okay, it's different school or program into there. And everybody study the computer programming, everybody study the programming, everybody study the math, everybody study the statistics, everybody may also study the business, okay? But you organize your own program, and then eventually that's the study of data science. So data science is not just programming, it's just not just data. So it's everything that I have talked about, okay? Everything that I have talked about. Data science including math, including stats, including data sampling, data science, including computer programming skill, including signal processing, that's in double E, including business, school, everything put together. That is your data science. Okay, that's your data science. So in a way, data science is bigger than computer science, yes, in some way. But if you really look at the data science major in college, it actually is smaller than computer science. It just means that some programming skill plus statistics. Okay. Is that okay so far? Hello, yeah. Is that okay so far? So that's when you pick the major, that's what they are, okay? And there are so many major, but everybody are studying the data science, okay? I'm trying to use that to let you understand what is data science, okay? So in a way, you need to do a lot of things, and those kind of different things is here, the data science, the job you need to do, okay? So let's look at big data. So if you get bigger data, okay, more information, you will make a better decision. That's what big data is all about, okay? So we get more information and examine it carefully and identify the trend. What is the trend? The trend is the more rule tell us the trend, right? Every 2 years, the performance double, that's the trend, okay? That's the kind of trend we kind of study, that actually is a trend that we study. So we try to find a trending, okay? Try to find a trending, okay? We try to find a trending and use the trending to make prediction and make correction and address the problem. Okay, that's the so-called data science. So data science requires big data. If no data, you just blind. You actually have no sensing of the information from outside. So basically, we are talking about big data. The bigger data, you will have less probability to make wrong decision. Okay. So big data, like, okay, when actually COVID-19 just get started, you just have one patient. So one patient, can you predict that, okay, what is the trending? We don't know, right? We don't know. But once you go up to 2 million, okay, we have bigger sample. We can know that, okay, this is COVID and this is not COVID, okay? We can start to look at it. Okay, and about when you go to like 10 million, okay, we already know that what can be the cure for it, what cannot be the cure for it. Okay, so with the bigger data, we can do more things. Okay, we can do more things. We know more about it. We know more about it. So that's called big data. Okay, the bigger data is better. So first thing is the server farm. Okay, server farm. So what is a server farm? So when the data becomes so huge, okay, you can no longer use your personal computer to process it. Okay, so computer become necessary that you need to be using the larger scale computers. Okay, so you need a data farm. Okay, so server farm sometimes also called a data center. You can put into data center with the server farm. So server farm is like this. You have a brain computer. Okay, brain computer. So you kind of build in a data center with a lot of brain computer. Each one of these brain is one computer. Okay, so you put a lot of computer in this data center to provide enough high performance computing. Okay, so scalability. When your data set, okay, become bigger and your system can still work, that is the so-called scalability. So scalability is the ability to to use the resource to adapt to the scale of the data. That's called scalability. So when the data get bigger, your system can still work. That's called scalability. Is that okay? Is okay?
Yeah. Yeah.
It's called scalability. So when data, so we try to actually put those things into a server farm. Okay. So Zoom, I believe, also has server farm. Okay. And Google has server farm. Facebook has a server farm. Okay. And nowadays we talk about a meta universe. Okay. So what's the main difference between meta universe and the current cloud computing? What's the main difference? Okay, so here we do here the AWS, Amazon Web Service, right? So another company put their server or data set in Amazon. So when you need to get data, you need to go through Amazon and then get it out. That's called cloud computing. So meta universe would distribute using the distributed system instead of just one Amazon. You may have different organizations and distributed, but everybody computing together and it form a meta universe. Okay, form a meta universe. So it's some sort of getting a new protocol to make everybody computing together. Okay. So that's a new industry right now is moving down. Okay. So with that, the whole system will be more scalable. Okay, more scalable, more free in a way. Okay. So one way that actually you can deal with the scalability is that you need to go through the use of metadata. Okay. Metadata is data about data. That's last time we talked about it. It's a description of data, but because you already tell people the size of your data, the so-called creation date of your data, okay? And you will also tell the file size. By doing this, we can find the proper processor to work on it, okay? And we also know whether this file is related to our computing or not. So that will make the scalability much better. Is that okay? Is that okay? So with the use of metadata, it will help your processing of the files. Okay, so that's called data. Metadata is about data. So it's some sort of label on the box, just like you send a package to your friend, right? But you really don't know what's inside the box, but you put a label on top of it, so people will know. Oh, okay, this one is a iPhone from Apple. Right, and they know it in the box is an iPhone from Apple. Okay, so that's called metadata. So metadata, for example, like in JPEG, you may see that what is the camera used, okay, camera model, and then exposure time used, f number used, okay, focal length, something like that. Okay, so that's called metadata. So metadata is used to help find and organize data. It's used to help to find and organize data. So you can use it to sort or group it. Okay, we can help you to sort or group it. Okay, it's called metadata. Okay. Okay, so problem of collecting and processing data, regardless of how large they are, data set can be challenging to deal with. Okay, and that actually sometimes is really huge. Okay. Fortunately, computer to help. Okay, so here, computer come. So data may be huge. So computer's main contribution is what? When the data set get bigger, get more remote, you need to have the internet. Computer will help. Okay, so computer science helping data science to collect data, to analyze the data, to do computing, sorting out data. Okay. So that's the main computing is providing the processing power. Okay, but data science by itself has its own story. Okay, so imagine that you make a Google survey to find out what class people like and at most in your school, you will create a form. Okay, so you create a form that is to ask a student, right? So in this form, you use a paper and people use pencil to fill it out, it's okay. So you distribute it. And then how many people can you distribute by paper? Maybe 10, maybe 20, maybe 100, right? Can you distribute this questionnaire to 1 million people? Probably not, right? So when you get the paper back, how many people need to help you to sort out the paper and then do statistics? A lot of people. But if you are using Google Form, how many? Maybe one person, one program that you can get it done. Is that okay? Hello, is that okay?
Yeah.
This is how computer come to help, okay? Usually, if you fill this one out with a paper, pencil, and people to collect the data, it takes months to finish it. That's number one. Second, after you finish that, you come back, there might be error. You need to kick out some error form, and you also need to process it and do tally and find out the final result. It takes a while. But now using computer, everybody's just clicking a button. You will know it right away, okay? So that's a computer science. So collecting data, sampling, and processing the data, okay? Actually, it's actually what? Actually, computer will help. But there is some problem, okay? When you require people to fill in his favorite class, he may fill in AP space CSP. He may fill in AP space ComSci. He may fill in AP computer science principle. He may use a lowercase. He may use this one leading capital. And he may fill in Miss Lossless fifth period. So what? So this one actually is mean the same thing, but what? But everybody may fill out different way. So because of this, you need to go to the next step. Cleansing of the data. How do you cleanse the data? You find a pattern. You find a pattern, right? You find a pattern. So everything like that, okay? Everything like that, you just use a standard format of AP CSP. That's it. Everybody, if you find it, it's this. You find it, it's this. If you find it, it's this. You realize it. So this one also need computer to actually do cleansing. So even data cleansing, you also need to use computer. Is that okay? Is that okay?
Yeah.
So that's a cleansing. After cleansing, you actually have a data, right? So there's a uniformity problem. You need to compile your data, okay? There's a uniformity problem, you need to clean the data. So cleansing the data can help you flag or remove invalid data or incomplete data, okay? But sometimes you will also lose some data because of that, okay? So it actually is a trade-off, okay? Then we have the data. So data set may be biased because of a few reasons, okay? There are a few reasons you may have a bias. Number one, when you distribute a form to the people may have their own thought, okay? So which kind of people you find, the data set may be biased, okay? So you send out a form to, say, a STEM student, you may actually get some result. You send out a form to some humanity-based student, then you may get a different result, okay? So in terms of fairness and sampling technique, there's a whole population. How do you evenly divide the size, okay? That's the question. That's the sampling technique, okay? Okay, so that portion you need to look at it. Try to avoid bias, okay? Try to avoid bias. Okay, the context of the survey also impact the result, okay? Also impact the result. So if you just providing some courses and you ask the 11th grade student you may look at it may be a lot of AP concept, right? So now if you actually design a phone in this way, here you have a stem field, and you put the AP, CSP, CSA, AP, CSP, okay. Actually also AP, calculate BC, AP, calculate AC, and you use the checkbox for people to check. I think this one's better than this, okay. And then English course, right? You actually put the English 9, 10, 11, 12 for people to pick. So you provide a form that actually with all the courses from the high school for people to do survey. It would be better than you provide a form that actually educate people in blind. Then usually the person would just, hey, right now I'm taking AP Physics 1, so let me fill in AP Physics 1. Okay, but actually, in fact, he may have done other bio in ninth grade. He may like it, but he forget he took that course before, right? Or when he fill out the form, he forget the course. So the way that you design your survey form is really important, okay, to avoid the bias, okay, to avoid the bias. How you actually design your survey will impact the result, okay? This is very important. So data will also be biased by social line or race or gender, okay? And also the work that people do, okay? Profession, okay? So, but just collecting more data doesn't make the thing go away, okay? You have to find a way to handle it, okay? So that the first step is actually data cleansing, okay? You clean out the data, okay? It's called cleansing, data cleansing, okay? Second one, now we are going to look into the data mining, okay? Data mining. So what is data mining? Okay, now the data has been cleaned, okay? So next step is data mining, okay? So mining means that there's some sort of ore, okay? You need to dig out iron, okay? There's some sort of treasure island, right? You need to actually dig to get your treasure out. That's called mining, okay? That's called mining. So your data set is this big. You have all kind of data in there, okay? You have all kind of data in there, and you need to find the information that you need. That's called mining, okay? That's called mining. That's called data mining. So with the current demand of data processing, okay, it's no wonder so many computer programs exist for the purpose. So here we actually, the next one is called data mining. Data mining is another name that I told you before, maybe last time. There's another term, it's called information retrieval. The Stanford has this one called information retrieval course and web searching, okay? So this one is actually a course in Stanford, okay? So UC Irvine also has the information retrieval course, okay? 2-to-1 information retrieval course, okay? Anyway, information retrieval means searching internet and dig out the data you need, okay? So that's a technique, a spatial technique. It's one course by itself. So that's called data mining, okay? So a common example is a spreadsheet program such as Google Sheet or Microsoft Excel, okay? You can use this program to record, multiply, organize the data. And if you are using number, you can write an equation and perform operation on it. So that's the Excel. So you can go to, there's a website called data.gov, okay? Data.gov. It's the government site for data.gov, okay? So here you can actually, you can find out the topic, Okay, so that's assume that, okay, right here we actually we are interested in the energy. Okay, we are interested in the energy. So we will try to find, okay, we try to find data. Okay, so try to data, you are actually we are interested in oil reserve. Okay, we're interested in oil reserve, and you will find some data here. Okay, let's try differentiate. Let's actually try go back. Okay, let's actually try data. Okay, let's actually try. Here, let's go grocery store. Okay, so grocery, by searching grocery store, I do find some file. Okay, so let me download the CRV file. So this is a CRV file I download to some location. Okay, I'm not going to process it. It's actually too big. Okay, so let me just put it in the local. Okay, so here let me create lecture 3. Okay. Okay, so what I want to do is like, okay, this one I download. Okay, this one I download from the data.gov. So this one is Excel file. And it is a data set. Okay, it is a data set. So the data we get is over here. It actually is a data set. Okay, so here let's actually do column with adjusted. Okay, so this one is a data set. You see, it's a data set of different store and ages. Okay, whatever. But the data set is not huge. But it will tell you this is a data set. So here in data.gov, they give you all kinds of the data. It's one of the largest data organization. Okay. Another location is UC Irvine. Okay. UC Irvine Machine Learning Repository. Okay. This one is the largest one for universities for machine learning. Okay. So you have Irish, adult, wine, okay, wine quality, heart disease, okay, banking marketing, all kind of data set. Okay. Is the largest one in the US in the US. So data science in Irvine is very good. Okay, computer science also, but engineering science is a little bit weaker. Okay, but here you have the repository. So what we want to say here is, before you do mining, you need to have a data set. Okay, and data set usually you can use a spreadsheet to organize it. Okay. You can use the Excel or Google Sheet to organize it. Okay. Okay, so you write everything into the Excel. Okay, into the Excel. Now the next thing is that you do a text analysis. Okay, so text analysis is finding a pattern within the written piece. Okay, into the text analysis, and identify the patterns. Okay, and you create table and diagram. Okay, and you such as line and then bars, graph. Okay, visualize your data. Okay, and create visualization of data and so convey your idea of the trend. Okay, so here the next thing is that getting the data, trying to create a trending. Okay, trying to create a trending. So here let me actually try to find some Excel file that I have. Okay, try to help you understand what it is. I cannot recreate it, but I do have some data we had before. Okay, let me try to find it. Okay, CSP data below. Now this one. Okay, one moment. Let me look at the Python. Okay, let me do chapter 4. Okay, let's actually look at these Berkeley numbers. Okay. So this Berkeley number is, okay, right-hand side is the chart that I create, okay? It's not other people create, it's the chart that I create. So here I grab the data from 2009 to 2020, how many ECS degree and how many bachelor degree in computer science, okay? And then total. Based on this data, this is the raw data, okay? Here you have the raw data. Your raw data collected by this, okay? By the graduation result, we get this, okay? That's the total number of students enrolled. It's not graduation student, so number of students enrolled. By doing that, we actually do plot, okay? We create plot. We create plot like this, okay? So you can see the trend. The blue one is EECS, okay? Yellow one is computer science. So you do see that the computer science in BA actually right now have more people than EECS, but before it actually is 10 to 1, 8 to 1, okay? EECS just keep almost the same, and computer science admission grow like this, okay? The people of the CS major grow over EECS student now, but EECS keep the same amount, okay? And then total student keep growing, okay? This year we will see start, okay? But this is the so-called data analysis, okay? Getting the raw data, make it to the plot, okay? And then you showing the trend. The trend is that ECS is not growing. It is not growing. It just slowly move up a little bit, but not too much. And you still see CS is growing. Yes, it's growing. Okay. And there's a crossover somewhere around 2017. Okay. Somewhere around 2017, there's a crossover. So such kind of a study, we call it the trending, okay, trending. So you need to get the data set, put it onto some table, and then trying to do analysis, okay? So data processing allows you to make table and diagram, okay? And do visualization of the data. Now let's jump ahead to the Excel portion, okay? So Excel give you some way to put the data in, okay, put the data in. So you have the bar chart, column chart, line chart, pie chart, histogram, data label, this different thing, okay? Data label, data marker, data series, plot area, legend, data point, okay? So you need to have a data, so you have a data series. So a data series means that a line is called a data series, a column is called a data series, okay? So who is a data series? A data series in our Berkeley case, ECS enrollment is a data series, okay? CSBA is a data series, okay? Year is a data series, okay? Total is another data series, okay? And sometimes 29, okay? Sometimes you can also call year as categories, okay? So the category is like 2009 is actually a category, okay? So ECS line is actually, this one by itself is a series. So if you look at the chart over here, it actually had a series 1, 2, 3, okay? Series 1, 2, 3. So this one triangle, we call it the marker, okay? Data marker. This one is label, okay? Label. And this one here, we call it data table, okay? The area here, we call it plot area, okay? Plotting area. So these are the terminology when you actually look at the chart, okay? And this kind of chart that we draw is called line chart. Line chart will show you the trend, okay? How the data grow, okay? That's called line chart. So in the exam, you'll see different kind of chart. Remember, the data series is one array, okay? You can say that one column is actually a data series, okay? You can also look at it as one array, okay? One array of data is actually one. And this horizontal side, we call it a category, okay? category. So important thing is the chart it do like this. Okay, you have the chart title here, chart title, axis, vertical axis title. Okay, data table on the bottom. Okay, horizontal axis. Data label is the label put over here. If they use a triangle, that's called marker. Okay, legend is this portion. Okay. Okay, anyway, it's the basic chart structure. We just show you some basic, okay? And then you have this kind of thing. This one's called line chart. Okay, this one's called line chart. Line chart is you have a data point and you use a line to connect that. That's called line chart. And you may have bar chart. This one's called bar chart. Bar chart, okay. And you have this one, it's multiple line chart, okay? So they are different chart. Column chart is bar chart, okay? Column chart is vertical bar chart. Horizontal bar chart, sometimes also called bar chart. So, and you have line chart, pie chart, and scatter chart, okay? So you have chart wizard, you can choose which chart you like, okay? And line chart is, a column chart is a vertical line chart, vertical bar chart, okay? And you have the bar chart, okay? And you have the line chart, okay? And you have pie chart. We have scatter chart, okay? Here, let's see. We have, let me see, Sunny, okay? Sunny Yen, let me ask you a question. What's good about this column chart or vertical bar chart? What's an advantage of this chart? This kind of chart.
You could compare things.
You can compare things in the same category. Okay, good.
Okay.
Next one, Nathan, yeah, okay. How about this vertical, horizontal chart?
You can like also compare things.
And the difference between vertical and horizontal.
It's just like the axes are switched.
Yeah, they are switched, but when you put it vertical, what give the people what kind of sense? As the chart suggests, okay, the horizontal chart, when you are controlling the completion ratio, it shows better. You know what I'm saying? People have a feeling, oh, this is almost done, right? You know what I'm saying?
Yeah, okay.
And that's a psychological issue, okay? So the two are the same data, but if you present it this way, people will feel, oh, okay, this one is higher, right? We just look at the chart. We even don't know what it is. We know, oh, this one is actually higher, right? Does that make sense? And we look at this chart, okay, this one almost done, right? We just look at chart. We even don't know what's going on here. We know that this one almost done, right? So that's about the so-called vertical, horizontal chart. So this one for, let me see, Michelle Wen, okay? What's good about line chart?
Sorry, what?
What's the good about this line chart? Line chart is the chart that have many data points connected by line.
It kind of shows like where they intersect and like
It actually shows the trending, okay? Show the trending. So line chart is the best chart to show the trending, okay? Line chart is the best chart to show the trending. So show the trending, we go back to our data science portion, okay? It actually shows us the trending the best. Trending, why trending is important? Trending is important because that we need to know about when our product should go to where. Is that competitive or not? That's a trending. Is that okay? So line chart will show the trending better and how much money we get. So how much money we get by the line chart, we know our growth, right? By the black line itself, we know the growth. And by the color line, we know the component of each department. Is that okay? Is that okay? So charting is very important. Okay, charting is very important. That will tell you what kind of data you want to present. Okay, so that's line chart. Okay, next one we have pie chart. Okay, so pie chart, this one for Kathleen Lee. What's good about pie chart?
It shows the relationships of each value in a single
Yeah,
series.
it show you how much percent you have. Okay, so usually if you show this one for market share, it's very good using the pie chart. Okay, scatter chart. That's one scatter chart. Let me have Emma. Okay, Emma Zhang. Okay. What's good about this kind of scatter chart like this?
It like shows the overall trend. Like you can find the line of best fit.
Overall trend, I would say line chart still be better. But compare the difference between line chart and scatter chart. Okay, it can show trend. It can show trend. Yes, it can show trend. But line chart, I think, show trend better than scatter chart. So what's special about scatter chart? Okay, trend is okay.
You can like determine the correlation or relationships.
Yeah, kind of. So actually, this scatter chart show the population better. We do see the trend. Okay, we can draw a line. That's not a problem. But you show you the population distribution. So basically, you may have 2 points here and thousands of points here. Is that okay? The scatter chart is like this. Is that okay? Hello?
Yeah.
So we know about the density, where actually it show up more. Okay. So that's the purpose of scatter chart. So here we do not teach you how to create this different chart. It takes too long. Okay. So I just show you different data chart. And that's the charting and trending. Okay. So here that's actually learn about this portion. Okay. Basically, we are reviewing. We are not actually going to the whole set. Okay. So basically, we do clean the data. Okay, we get the data, we clean it. Okay, and we actually present it in Excel file. Okay, and we start to do analysis, textual analysis, and trending analysis. Okay, and then we actually need to transform it. Okay, transform it in actually we make multiplication. Okay, we do calculation. We actually sum some column together. Okay, that's called transforming. Okay, and we filter out some data. Okay, so for example, some data too old, we just filter out that. Okay, and we combine and compare some data. But anyway, a lot of transformation can be done, and eventually we want to show some chart to convince people to tell the story. Okay, to tell us the story. So eventually, it's go to data visualization. After data analysis, that's data visualization. And data visualization, based on if there's no machine learning involved, it's only this kind of the Excel chart. Okay, and then we make report. Okay, then we make report. And that portion is easy. Okay, so let's see. So we can do this one, trend reporting. We can show you the ABC company's price trending. We can see the HDTV's trending. But this one is a vertical bar stack bar chart. It's a bar chart, but it's stacked. So by doing this, you can show that, okay, what percentage of the 52 to 65 inch HDTV is. Okay, the overall trend is shown. Yes, the overall trend is shown. But it also shows you the percentage of each category of the TV product. Okay, so that's trending. So here is a complete toolkit from data source. Okay, NoSQL, MySQL, and data warehouse tool. Okay, and data dashboard, score cards. reporting. Okay, so the whole thing is the tool package for data science. Okay, and data science also have a life cycle around data creation, data processing, data analysis, data preservation, data access. This one is also data storage. Okay, data archiving. Sometimes call it archive. Okay, and then data reuse. Okay, this is the life cycle for data science. Okay, and you may, before your data project, you need to find binding, find motivation, design the project. Okay, this is another way to look at it. Okay, to creating the data product. Okay, and you can search for Google Trend. Okay, you can search for Google Trend. So let's go to Google Trend. Okay, so Google Trends tell you how many people search on certain topic. Okay, let's go to Google Trend. So Google Trend is the statistic of some term that people search. So here the statistic term you go in. Okay, so you see recently this term just turned super popular, right? Okay, and this one, let's actually compare with something here. Let's actually do some the participant. Okay, let's actually check this, right? So here you see participant, nobody interested, everybody just interested in Ukraine. Okay, how about Russia? I think Russia will be equally important now. Okay, Ukraine, more people care about it than Russia. Okay, it's okay. So this is Google Trends. So you can also do something else. Okay, you can also do SAT. Okay, you can also do SAT versus ACT. Okay. You can also do SAT versus ACT comparison. Okay. So this one is the statistical data that Google collect of how many people do searching for a term. Okay, for a term. So let's see. Peter. Okay, Peter Shen, right? Peter, let me ask you, what's the, if you search that here for Google Trend, some line actually is higher than the other. What does this mean? Hello, Peter, hear me? Hello, hear me? How about Nico? Nico Wei, hear me?
Yeah.
Okay, so Google Trend is a statistic of the past 12 months history of how many times the SAT being searched by people versus how many times the ACT searched by people. So what are the data shown here that, okay, how do you interpret it right here?
ACT have a greater rate than SAT.
So more people search internet for ACT than SAT. So what does this data also interpret to you? Does people care more about ACT than SAT?
Yeah.
Kind of, right? Kind of recently, right? Yes. Okay. And does this indicate that ACT have more exam taker?
No.
No. You cannot make that decision. Okay. So this is some side of a question that AP Computer Science principle may test you. Is that okay? From this kind of data, what can you interpret? But you cannot over-interpret it. Is that okay?
Yeah.
You can only see what you see. And Google Trends show you how many people browse it. You can only see the trend popularity maybe, okay? And the trend probability. That's only thing you do. But you cannot indicate that exam taker. Exam is totally different from here. I browse more times doesn't mean that I actually will take that exam. Same thing here. If I say Toyota, okay, versus Honda, almost the same, almost the same. But can you predict that, okay, Honda and Toyota, their sales are the same? Maybe not. You can only know that people browse through the internet about the topic of Honda and the Toyota almost in the same same intensity. Okay, people just like both. But that means that Toyota has better sales or Honda has a better sale. No, sale is totally different. It just means that when people consider these two kind of car, they will compare them. Is that okay? Is that okay?
Yeah.
Okay, so that part is actually Google trend. Okay, we talk about Google trend. So Google trends, okay. Next one very important is that, okay, after you know about the trending, this is also true for ACT science, okay. They also want to test you on the trending, okay. What can you make conclusion and what you cannot, okay. And you need to compare the trend, okay. You follow the trend, some current event, social movement, or whatever, you need to work on it, okay. There's a long-term trend and short-term trend. You need to look at a time frame as well, okay. Then you need to be able to tell a story, okay. Tell a story. How to describe the data that you see, okay. How to explain why. If the explanation is not enough, you may need to do research more. So sometimes you do see two lines, one line going this way, the other line going this way. You try to explain it, but you still don't believe it. Okay, so why blue drop, red rise? Okay, you try to explain it, but sometimes you cannot explain it. So then at that moment, you need to do research. Okay, you need to do it. So why Intel sales is dropping? On the other hand, AMD is rising, right? Then you need to do research. Sometimes they are background information you do not find. You cannot find by the trending. You need to do research, such as, hey, let's look at their GPU sales number, okay? To do research, you may dig out some detail, okay? So that's the tell story and try to find the explanation, okay? And this portion is a visualization of the data. So you analyze the data, okay? So by collecting the data, right? And then you organize your data in the data structure or Excel file. Then you do data analysis. You draw the diagram, show the trending, okay? And you go back to collect the data, okay? So here you have the whole data science life cycle or from start, from business understanding, getting the data, okay? Trying to model it, try to deploy your data product, okay? Data product means that Google trending is a data product. So here, let's pick it, Google trending as an example. Google trending by itself is actually a product, okay, by Google. Okay, data acquisition is that everybody browse the website, collect the browsing record, and Google will do that, okay? And those kind of data would use a model to learn it. So here you may have machine learning. Okay, eventually you provide a Google trending result to tell people, okay, who is browsing it, how many people browsing it, something like that. Okay, so here is another one of the data life cycles. Okay, okay, this portion about that. Okay, digital divide. Okay, digital divide. Digital divide is like people are divided because of their social standing or family income or locality. Okay, so they have they have quite different way of accessing the technology. Okay, so people are not equal in digital era because people may be divided by the digital tools, especially some far off space places still do not have computer. Okay, so this year AP Comp Sci AP Computer Science courses this year just passed 50%. Okay, just passed 50% for the U.S. high schools. This year, 2022. Okay, the first year to pass 50. That means that still maybe 48% of the people of the high school in U.S. no AP CS at all. Okay, still half of the school in U.S. do not have computer education. So digital divide is very a big issue right now. Okay. Okay, so that's that. Okay, I don't go into the. Let's look at this video. Okay, bridging the digital divide. Digital divide is a big topic.
This year, travel smart with French Bee. Fly from Los Angeles to Paris from $279.
I was born in 1960. And if you can't tell by that image, I grew up in the analog world. I used rotary telephones and I solved complex math problems with the
Sorry, let me adjust the volume, okay? A little bit too like. So this one I try to show you what is digital divide. Okay, digital divide by itself is a big topic in the AP. Okay.
Pencil and a piece of paper. What I knew of the world, I got from watching black and white television and reading an encyclopedia. And no, dinosaurs were not roaming the earth then. Look, being born in 1960 offered me a rather unique opportunity to witness the dawn of the digital world. I was in my late 20s, and since that time, I have spent.
Okay, he said that 1960. Yeah, 1960, the computer just get started. Okay, he was born in 1960. I was born in late 1960 as well. So basically, 1960s is about the time people start to use computer.
Nearly my entire adult life in the technology industry. I've seen some amazing things. I have seen mainframe computers the size of this stage reduced in size to fit into my back pocket. I witnessed the birth of the internet and web browsers and social media. Right now, from this stage, using this device, I can control no less than 6 internet-connected devices in my home. Even more incredible, doctors today can remotely diagnose and administer medication to patients anywhere there's digital broadband connectivity. Yeah, the digital world is pretty amazing. And it has really been a profound, it has a profound impact on the direction of my life. But it's come at a cost. Millions of people throughout the world, many right here in South Carolina, are being excluded from the digital world. They call this exclusion the digital divide. And I am here today to talk to you and introduce that topic to you and to show you the plan that we have for making it a thing of the past. Now, I want to use this image of the London Underground to help us visualize the digital divide. The London Underground is made up of several elements. The train that takes us back and forth between our destinations, the platform where you stand to access the train, and the gap. And that's the space in between the platform and the train. Find the gap.
Okay, so he emphasized digital divide is the platform and the trend, right? So actually you have a platform and a trend, and he said that there's a gap. That's called digital divide. So what he's trying to say is that there's a trend, right? Trend is keep moving. So digital world is like the trend. It keep moving, right? Keep moving, but some people actually can jump right in because there's very little gap. But some of them actually do have a big gap. So actually really high, okay, they cannot get in, or really low, they cannot get in. Okay, so there's a gap between the platform you're standing at to the train that you're jumping in. That's different. And it's a different gap from his word. He indicated that the social income level, social standing, also the location of where you are, maybe race also sometime, okay, and maybe also gender, maybe sometime. These are the issues that divide people from being able to get into the trend, okay, from people to get in the trend. So trend is still going, but not everybody is welcome or be able to find a seat for them. That's what the problem is right now for digital divide, okay?
There's actually a life lesson there. Now, for the purpose of this discussion, what I'd like us to do is to imagine for the moment that the train is the digital world and the platform is how we access it. Now, there are two types of people standing on that platform. Those who can get on the train and those who cannot. Those people that can get on the train, they have the necessary skill and knowledge and economic ability to do so. For them, it's just a simple matter of walking over the gap and getting on the train. For those people who cannot get on the train, they don't have the skill or knowledge or economic ability to do so. For them, the gap is already way too wide to try to cross. And so they're left standing on the platform. This is the digital divide. In 1995, William Kennard, then chairman of the FCC, stated, in a society where we are increasingly defined by our access to information and what we earn is what we learn, if you do not have access to technology, you're going to be left in the digital dark ages. Let's fast forward to today. You might be interested to learn that the digital divide, that space, that gap between the platform and the train has continued to grow wider. Let me put this into perspective. In the US, there are over 34 million people who do not have access to the digital world simply because it's not offered to them. And when it is offered to them, in many cases, it is far too expensive for them to afford. Additionally, 1 out of every 4 US adults are either illiterate or they have a very limited literacy skill set. And I'm not even talking about the people that don't have the technical skills in order to do something with that connection. These statistics define the primary factors attributing to the growth in the digital divide: access, having the ability to actually obtain a digital connection, and understanding, having the necessary knowledge and skills to be able to do something with it. Today, we have global, federal, and locally funded projects that are actually addressing access to the digital world. We can actually visualize the day when digital broadband connectivity will be both ubiquitous and affordable. Understanding, having the required literacy levels and technical acumen to do something with that connection, those problems have proven to be significantly harder to solve. Now, I mentioned earlier that I have been in the technology industry for most of my adult life, and that's over 30 years. Really old guy. And even for me, at times, I have difficulty accessing and understanding.
Okay, I think this one you can continue to watch, okay? It's called Bridging the Digital Divide, but basically I just want you to know about what is digital divide, okay, and what can be tested in the exam. You need to get a key idea, okay? Digital divide is because that you have different social or economical standing, so preventing some people to get access to the digital technology, okay? So that actually is that. Now let's actually look into the next issue, okay? So we look into the digital divide. You can download the PDF and you should still have the link here, okay? And you can look at it. You can look at it, okay? You can look at it. So because we are reviewing, so I don't have that much time to do it, okay? So now let's look into the next topic, data regression, okay? Data regression, qualitative research, okay? Quantitative research, okay? And then AI, okay? Let's get started with qualitative research. So research has two types, okay? Research has two types. Research basically has two major types. One is called qualitative research, okay? You go to summer camp in the university, you try to do research, you have two types of research, qualitative research and quantitative research, okay? So quantitative research is studying the relationship between data. This is a data science. We usually is more quantitative, okay? More quantitative. So quantitative research is that we try to find out the SAT score and the related college admission result, okay? That's quantitative. Qualitative research sometimes is assessment of value, okay? Of value. So something like is digital divide series right now or not, okay? So this one, it usually something that you cannot use a very simple word to describe it or use a number to describe it, but you need to make a personal judgment, evaluation, okay? And then you need to study something and make such something, okay? So here say, for example, okay, some people say that communist is good, some people say communism is bad. And is that good or bad? I don't know. I don't give a personal judgment here, okay? I don't give personal judgment here. But to study it, it actually is a qualitative study. You cannot collect data, okay, this one, we have this and so, and it's good, or that's bad, okay? This kind of thing in actually involving the personal judgment or the value system, it's called qualitative research. So the word qualitative implies emphasis on quality of something, okay? So that one is qualitative research, okay? So here we don't spend as much time on qualitative research. Some business school do teach you how to debate, how to do how to do price negotiation, conflict handling, conflict negotiation, right? That's actually MBA's topic. But something like engineer don't care about the conflict negotiation, okay? That's beyond their scope. So qualitative research usually is numbers. So we go into the statistic numbers and numerical analysis, okay? This is qualitative research. So this qualitative research would have machine learning and bias. Okay, we'll talk about this later. First thing, let's go back to the data. Okay, go back to the data. So here we have three major machine learning. Okay, three major machine learning. One is called regression. Okay, regression. So let's look at regression. Okay, first. So we have three major things for machine learning: regression, classification. Classification means that why this is the dog. Okay, regression means that, okay, when I have a gray color image, how can I restore it back to color? That's called regression, okay? And third one is called clustering, okay, clustering. So we introduce these three terms right now. Let's go back to the regression first, okay? So regression, what is regression? Okay, regression, so data regression. The data regression is one way of the machine learning. It's the most popular used method and the most traditional way to do it. Okay, so basically we have data, right? We have data, and our stock price, we may use a 5-day moving average, the red line, to model it. Okay, so this one is one sort of the regression. Okay, so the regression analysis main idea is to find out the relationship of the data and trending, okay, and the trending. So linear regression is like your data may be like the orange one. You may find a curve to match it. So the curve may be like this, maybe second order, maybe first order, maybe multiple order, okay? So we say this one overfitting. You kind of provide the model too much detail. Okay, this one is about right. This one may be underfitted. So these are different regression. So if you use a one dimension, this linear line, we call it linear regression. Linear regression using a AX plus BY to model it. Okay, this one is called linear regression. Use a line to model it. It's called linear regression. So linear regression may not fit it well. Then you can use quadratic regression, third order regression, different type of regression to match the data. Okay, this we don't go into the different details. So regression is estimation. Okay, regression. Remember, regression is estimation. Estimation means that I have data point like this. Okay. And then I roughly find out a line. And using that equation to estimate the real data. Is that okay? Is that okay? So from the red data to find this equation, that's called regression. But we use that green function to predict the future. We use that to do estimation. It's okay? Hello?
Yeah.
Yeah.
Okay. The first purpose regression is used for estimation. Okay. So here I just shortly talk about it in this way. And that's a supervised learning. Okay. Second way is called classification. Let's look at what is classification. Classification is that this is a dog. That is a white hat. Okay. So how you classify that is a dog from the image or head from the image, that's called classification. Okay. So typical classification problem is this is a classification. Your handwriting, you try to I write something. Okay, I write something. So here, if I do this thing, right? Should it be recognized by 2 or should it be recognized by 7? This is called classification. So classification is minimization of error. You can also call this one as pattern recognition. So this one we call it what? Classification. So classification is also pattern recognition. And pattern recognition based on the minimization of error. So we have this 7. We try to find a pattern that have minimal error. Is that okay? Is that okay? So second thing actually is called classification. So classification is that we have so many words, we try to use math to determine whether this one is a 5 or is actually a 3. Classify, sorting things out, right? We have a data, we try to classify it. Is this alpha or is this A? This is called classification. Grouping, try to sort out which group it belongs. That's called classification, okay? Regression is do estimation. Who is the best estimation to me? That's called regression, okay? Third one is called, third machine learning is called clustering. Clustering happening in when we do this, okay? Clustering is a crime prediction using k-mean clustering, okay? So we, based on the report of the crime, okay? Based on the report of the crime, we try to determine the insurance rate for car. So we divide it into zones. Some sort of zone, we call it clustering. Okay. So say let's assume that this one actually is D region, okay? D is dangerous, okay? D actually dangerous. And we may have C region, okay? We may have A region. So A, B, C, D region, you sell insurance at different price, okay? And how you actually figure out which price should you be selling? That's called clustering, depending on your source data, where you live. Is that okay? Is that okay? Hello?
Yeah.
Okay. So that means that actually in A region, there's nobody carry any bomb? No, maybe. There still may be some bomb, but compared to different region, different other region, A is comparatively safer. Is that okay? A is comparatively safer. A is comparatively safer, so basically, this one is called clustering. So here we actually just show you briefly about 3 different ways to do machine learning. Okay, machine learning means that use a past history to help you to do estimation, or use a past history to help you to classify, finding out the word, or use a past history to helping you out to divide a solution space with zones. Okay, so that's different way for doing clustering, machine learning. Okay, and we basically what we collect the data, right? We do the analysis, then we would like to bring in the machine learning to do study, right? So if we do not bring in the machine learning, we use a charting, we know about the trend. But when we bring in the machine learning, the past data that we can use can provide us the regression, can provide us the classification, can provide us the so-called clustering computation, okay? And this different way of the computation will help us to achieve, make the product, data science product goal of much higher value because of this machine learning. Is okay? Without machine learning, you can only do some charting. So with the machine learning and AI, your decision quality improve, your data product is more useful, okay? So right now we are 10:59. Let's come back on 11:05, okay? Let's have a break. Okay, any questions so far? Any questions so far? Hello, any questions so far? You hear me?
No.
No question? Okay. Hear me, right? Everybody?
Yeah.
Okay, anyway, we actually finished this lecture 3, data and information, okay? So I'm going to actually get to the problem set, okay, problem set. And let's look at the problem set, okay? Here I'm using the parents. So this parents originally you need to turn in this week, okay? You need to turn in, you should already, it already due, okay? You should already turn in. But right now the turn-in rate is not high, okay? Please try your best to turn in more solution, okay? So anyway, let's actually work on it together to review the topic, okay? We'll go back to our slides if needed, okay? So let's see. The first one actually is computers are described to processing data iteratively. What order will the computer process the program? Okay, so it's A assigned with 38, B assigned with 54, C assigned with B plus A, displays A plus B. So this one, the answer is C. Okay, this one I don't need any student to help, but it is, I don't know what's the purpose of testing this. It actually executing in 1, 2, 3, 4 order. So this one actually just be very simple. Number 2, okay, we cannot finish the whole unit here, okay. There are 78 problems, so you need to work on it. I just use these to explain how can we answer the question, okay. So number 2, I will get a student to work on it, okay. One moment. This time, let me get started from the top, okay. Top will be your first name is in alphabetical order, okay. Alex Zhang, okay, Alex, number 2. What is the answer? Why you pick that, okay? Hi, Alex, hear me?
Yeah.
Yeah, okay.
Probably C for number 2.
What's your reason?
The data doesn't mention anything about weather, so we can't really include
Yeah,
that.
okay. So here you have group of whale, right? So we have group of whale. The group of whale, and you put some tracking column on it. Okay, so say this group of whale, and you record it. It actually it has a trajectory of this. Okay, they move it in this way. Okay, so you know that there's a time and day and where they are. So you actually can see which time where they are. Okay, so apparently how many miles they travel? Yes, we know. Does animal travel in group? Yes, we know. Different animal, other track animal. Other track animal means that you may also put the column on some shark. So you can also look at it, yes. So on weather, we don't have information about weather. So you cannot over predict something. So the answer is C, okay? How about D? D is saying that, okay, in geographic location, in what geographic location that the animal typically travel? Yes, we have the geometrical location of the sea mammal, okay? Number 3, let me have Emma Zhong, okay?
B.
Okay, B. Large data set are used for finding pattern. Okay, here you find pattern, so it's a data science to predict future usage. Okay, key word is this word future. Okay. Calculating monthly bill. Calculating monthly bill, you have so many water you use, so much electricity you use, whatever. Is that future use? No, that's current bill. That's current bill. That's not future. It is a no future. Okay. Second one, using the past purchase to recommend possible purchase. Possible is future. You say that last 3 months you always buy some shoes, so I suggest you to buy shoes. But did that happen? No, that haven't happened. So that's future. So one, identify large spending address. You have a lot of transaction. You know that somewhere come from first tree, number one H3. There's a person keeps spending. That's still not future. That's the current. It's just knowing that who spending the most money, so she's not. D, identifying time in which most purchases are made. Yes, you can find out which one, what time, what month, or what day most purchases are made, but that's not predicting future, so this one is wrong. Only B has relation with future. Is that okay? Is that okay? Hello, is that okay?
Yeah.
Yeah.
We are trying to actually teach you the different problem solving skill, okay? So let's jump a little bit because we did not work on every problem, okay? Let's jump a little bit. Next one, Catherine Lee, okay, number 5.
B.
Okay, your choice B, okay, no problem. Number 1, that's actually, you must know about what's a show SMS, okay? So Catherine, what's SMS?
Short message service.
And what? Have you used it before?
Yeah.
So show service message actually can only carry as many as 160 character. So in the old way, we had the pager, but later it was replaced by show message. But show message is good when people want to broadcast some urgent message to a lot of people. Show message is good, okay? Usually like you will see some alert. Some people send on freeway saying somewhere there is a gunshot, okay? So that kind of information is very important and very important, very urgent, okay? So that's the show message. So once the show message we converted to binary form. So it been originally it was text form, converted to binary form, okay? So from text form ABC converted to 1010, okay? And then sent to radio wave, okay? And then show message travels through the control tower. So control, it go to some control tower, okay? And it arrived later into the center, okay? And then it will be stored or sent immediately, okay? So according to the show message, the cell phone carrier send out metadata. So keyword is this one, metadata, okay? So which of the following is not metadata? Not metadata is something that contains. So B, you can pick right away, is the content, okay? Content is not metadata. Metadata is how many words the message is, when it's sent, when it received, where it received, which cell phone sent it, okay? Nothing with the content. So non-metadata is the content, okay? Number 5 is this. You must remember what it is, okay? So number 7, let me have Malcolm McPherson. You have so many data, and then which one you cannot determine. Malcolm, hear me? Hello?
Yeah.
Okay.
Would it be a B?
Why B?
Because it doesn't say like the popularity of the colors, it just says the colors.
No. B is correct, but not because of that.
Because it didn't talk about a season in
Yes, it didn't talk about a season. Your whatever information you have, there is no season, okay? Yeah, well,
Okay.
this actually we have a discussion session. Anybody has opinion, you can say it, okay? But we have one student to mainly work on it. But if you have a suggestion or you have idea, you can say it, okay? So basically, you choose this one because the keyword season, we don't have that. So basically, in this type of problem, what we are looking at is that, okay, given this information, which I cannot determine, usually it's talking about something that you don't have, some information that you don't have, okay? Number 8, let me pick another person, okay? Michelle Wen, okay, Michelle, number 8. Because each problem you have 2 hours, you need to solve 74 problems. So each problem you have less than 2 minutes. Okay. So the reason why I want to do this kind of the practice is that trying to help you to identify which may be the key idea you need to grab when you look at the problem. Otherwise, the word problem is so long, you may read it for a long time. We try to minimize your time to answer it, okay? So Kathleen, I'm sorry, Michelle Wen, okay, sorry, I'm calling the wrong person. Michelle, what is the answer for number 8, okay, and why?
A,
Because of what?
it, like, shows the public's interest in like.
Okay. Number A, you are using the Google Trend. We just talked about Google Trend, right? So Google Trend main idea is that you will show the popularity of the topic, right? So just look at which one has the popularity of the topic. So the day that what day the cheapest day to book a hotel? Is there popularity? No, right? It's actually which day? July 4th, right? Whatever. But that July 4th come related to which day? No, that's not trending. That's nothing to do with trending. July 4th is the cheapest day of the year. It will be a fact. It's nothing to do with trending. Is that okay? So this one's not. Second, the cost of the gas powered chainsaw. Same thing, how much you sell is not voted by people. So it's not trending. Is that okay? D, the length of the whatever thing, is the target rod, some rod, okay, some rod, okay, whatever. Actually, well, I don't know what it is actually, okay. It's a race, okay, whatever, in meter. So how long it is that something that people can vote it or people can call in to search for it? The length is nothing to do with it. It's not a popular. Only how much people concerned, that one is related to the popularity. Is that okay? So A is the right answer. Yes, A is the right answer. The keyword is popularity, is the Google trend. We talk about it in the class, okay? Okay, so the reason why we teach you in that way, usually there's some problem that you need to use this concept, okay? This is one way we actually look at it, okay? So number 10, let me have Nathan, okay? I'm jumping one or jumping two sometime. Number 10, Nathan Chen, okay?
Is it A?
Okay, so this one again is that the information doesn't have, right? The information doesn't have. Let's look at what the information they have. Students' highest grade, parents' highest grade education level, GPA, okay, intended college, okay, intended college actually is maybe computer science, but that's only intended, okay. C, actually D, actually the where they want to go, okay. Whether they want to go doesn't mean that where they will go or where they will be enrolled, okay. So number 10, A is correct because your intended college doesn't mean that it's actually where you got accepted, okay. So A, the data doesn't have that. Yes, you're right. Okay. Let me see. Okay, this one is a little bit harder. Listen, yeah, okay, number 11. This one is a little bit harder. That's why I don't jump too far.
Is it D?
Why D?
Since if they have different strengths and experiences, they can like use those strengths to create like better algorithms at a faster pace.
Different strengths, experience. Okay. What is the key word in this problem? What should you look at? It is entire group, different member, one member, different member, entire group, different member. Okay, so it's who work on it. Okay, who work on it. So let's say why B not correct in your word?
Because one member has to implement everything, like as they're completed.
Okay, no, 1 person or 2 person, 10% or entire group doesn't matter. C had the entire group, so why you don't pick B or C?
Because like each algorithm has to be created by a different member, and like some members might be weaker in creating certain algorithms.
No. Here there's a trick. This problem I pick it because there's a trick. Okay, so here the question is that which is the most effective strategy to creating algorithm, right? Implementation has nothing to do with the creation of algorithm. Implementation is that you got an algorithm, you try to do coding. So implementation has nothing to do with the creating algorithm. So basically, you have 1 person to implement it, 10 person to implement, 1,000 person to implement, finding 300 girls to do the implementation. Nothing will matter about the creation of the algorithm. Is that okay?
Yeah. Okay.
Creation of the algorithm basically based on expertise. So if I go to a trading company trying to write a trading algorithm, the guy must know about computer science well and also the stock market well. So that's the strength, the experience come in. Is that okay?
Yeah. Okay.
You cannot find someone who doesn't know about stock market and do the coding. So here different member is not enough. Entire group is not enough. Okay, why don't we just have the entire group to develop algorithm? Even more people than each algorithm, right? So basically, it's not the right way. You have some people have specialty A, some people with specialty, some people with specialty C. You should use a person in the right specialty. Is that okay? So the answer is D. That's correct, but it basically you need to look at it more carefully. Okay. Okay, next one, let's see. Number 12, this one's a P2 problem. So it's interesting. Let me have Nathan Ye, right? Nathan, I call you Heaven, right? Nathan Ye, number 12. This one is a P2 problem, okay?
Wait, me?
You're done, okay? Sorry. There is a Nico Wei, okay, sorry. Hi, Nico, hear me?
Yeah.
Number 12. So why a team and not alone? Okay, this one is the quick asking you why teamwork.
Is it B and D?
B and D. Let's see. Okay. B doesn't help.
I think it's A and D.
A and D, yeah. Why B doesn't help?
Because socialization doesn't
Doesn't help you to do coding, yeah? Is that okay? Doesn't help you to do algorithm. Let's go to the coffee room or kitchen and have a cup of coffee for 10 hours. Can that speed up your development? Okay, you have work-life balance, but not that balance, okay? Is that okay? So it's not a main idea. You do need to have some break, but not too much socialization will help you. Is that okay? C team member will compete. Compete doesn't actually help the developing of algorithm. So C also is wrong. Is that okay? So that's A and D. A actually different people have different understanding. Yeah, you can help debug, help something. So A is okay. D different skill. Yeah, different skill. So teamwork better than one person because people coming from different background. Okay, that's a key idea. Okay, so let's see here. Okay, number 14. Number 14. Let me have the next person. Peter Shen. Okay, Peter, hear me?
Yes.
Yeah.
Yeah.
So number 14. Okay, number 14. Here it said that okay. Which we have series 1, 2, 3, 4. So series we have a table. Okay. So 1, 2, 3, 4. Which one has the largest growth? You only saying 1, 2, 3, 4. So you just pick one. Series 1, 2. Which one has the largest growth?
Wait. I mean the wait. 2.
Okay. So this problem actually is you had a bar chart, but you do connecting the component, you'll see number 2 grow the fastest. Is that okay?
Yeah.
The trending, number 1 is like this. Okay, you can compare. So yes, the answer is number 2, but this is a kind of problem when you see it showing you that who grow fastest, you can connect it, make a line chart. It's better to know it. Okay. So number 15, let me have next one. Sunny, please. Sunny Yen. Number 15. I'm sorry. Okay, this is again a which one cannot be determined problem. Okay. So see who is missing, who X for some data we don't have.
C.
Number 15, C. There's no information about which bakery, right? So keywords bakery we don't have. Okay, good. That's actually the right answer. Okay. Let me jump a little bit. Okay. This one repeats, so we don't do that. Okay, number 18. Okay, number 18, go back to Alex Zhang. Okay. Number 18. A face-to-face interaction makes it easier to share and discuss information used in project. Yes. A, actually face-to-face would improve that, yes. B, face-to-face interaction are more convenient. No, it's not more convenient. Zoom more convenient. You do not need to travel, okay? C, interperson methods such as messaging are more expensive. No, messaging is less expensive compared to you actually sitting together. Need to have one office and one. Some people may need to travel. Okay. D, face-to-face method are more time efficient. No, Zoom is more time efficient. Okay. So this one is A, correct. Okay. Number 19. Let me have Emma, please. Number 19.
B.
Why does more actually data analyzing tool have the option of creating the method, creating graph, because we want to have the data visualization, right? So it's easier to code the graphic based data analyzer. No. Coding graphic is actually harder. No, it's not. So try again. Is that okay? C is not. You say C, right?
I said B.
Oh, you said B, okay. Yeah, it get better to do trending, yes. Number 19 is B, okay. Sorry for that, okay, sorry. Okay, number 20, okay, number 20, let me have Kathleen D, okay. Pick 2 problem now. Why you want to have a graph instead of using table or raw data?
B and D.
Yeah, B and D. Data representation. You want to find a trending and easier to interpret. Okay. So number 20 is B and D. 21, okay, 21 trending again. Let me find another one. Malcolm. 21. Pick 2. This one pick 2 problem. Okay.
Is it B and C?
Google Trend, okay. Google Trend will say that which one is more popular, okay. More popular in terms of searching, okay. So that's really one by one, very carefully. Google is the largest search engine, so the answer is guaranteed to be more accurate. Can you say that? No. B, Google is a more popular search engine, therefore it has a larger data set. Yes, it has a larger data set, okay? So not because it's a larger data set, but a larger data set and creating more accurate data, yes. Because you are doing trending, more data, more accurate, okay? See, the less popular search engine might primarily be focused on certain people, yes, that have bias. Smaller data set has a bias, okay? So B and C, yes. The Google track popularity of website. No, it doesn't track the popularity of website. It tracks the popularity of the search keywords. Is that okay? Google trending. We are talking about Google trending. It's checking about the popularity of keyword. Okay. So now the popularity of website that would actually say Yahoo is very popular, but that's people search Yahoo help you to know about anything. No, it's a general website. Is that okay? So that we care more about website. Okay. I'm sorry, care more about the keywords. Okay. 22 not important. 23, let me see. Okay, 23. Let me have Michelle Wen. Okay, Michelle. '23. Hello.
Yeah.
Which one?
D, because
Why D?
some books have too many letters that it's hard to sort.
No. Here it said that D is the answer, but not the reason you provide. Anybody know what's the reason? That's because the number of letters in the title is nothing to do with the filtering. Okay, here we have a library system. We want to know about is a scientific fiction or it actually is so generic of the book. We help out you to fill out book. Yes, you go to library, you try to find a book. It is a scientific fiction or it is actually a STEM textbook. The generic textbook will help you to figure out whether it's a book you want to get or not. Yes, okay. Second, the library and all libraries in the system have a copy of the book. There's no copy, you don't need it. So this one, yes, you need that information. The author of the book, yes, you need to know whether it's the right book or not. Okay. The number of letters in the book's title, no, usually you are not interested in it. Okay. You can have say a book called Linear System for Electrical Engineering. You can have a complex linear system for transform-based electrical engineering system and signal, right? So the number of letters doesn't matter. I'm curious about linear system, so I will find a book with that generic of the book is important. Number of letters in title doesn't matter. Is that okay? Is that okay? Because the number doesn't matter. It doesn't mean that you cannot sort out. You can always sort out, but actually it doesn't help you to find the right book you want. Okay? Must focus on the nature, what you really want to search. What kind of the data you don't need. Here is like what kind of data you don't need. When you fill out some entry from the library. So D, the number of letters, I don't need that information. The books say linear, okay, one word, good enough for me to find it because I need that linear system, okay? Okay, number 24, let me have, see, which one I call Michelle. Next one, Nathan Chen, okay, Nathan. This one is pick two problem, 24. This kind of problem, you must find a keyword, okay? Keyword, some keyword that will help you.
Is it C and D?
C and D, okay. A small business keep track of the profit and expense daily. So actually, you know about how much business you do every day. So there's a trending of that, okay? So the following features of spreadsheet, which would be the most use of the business. You got the information of daily profit and expenses. What you actually want would be able to do, okay? So see, A, the ability to create a graph daily. So A is the answer. B, create 8 map chart. Wait, you have a profit and expense. What is map chart? Do you know that there is a Google map or something? No. No. You don't know where the purchase is. You only have the profit and expense. Okay. C, the ability to have specify the role updated automatically. Yes, there is a spreadsheet. Some of data you can update daily. So C also the answer. How about D? An error checker find out the error in the formula. Wait, I'm talking about profit and expense. And what is the key point? Oh, is this related to it? No, this is related. This is the job done by Excel. I don't care about it. Is that okay? Hello, is that okay?
Yeah.
Okay.
I don't care about D. That's something that Excel should give me. Spreadsheet application, right? I'm doing business. Why should I care about the formula is correct or not? That's the job done by the spreadsheet. So I care about what? Can I make the graph easily? Yes, I care. Actually, can I update my data? Yes, I care about it. Google Map, where is Google Map? I don't map it with the Excel. It okay? Something you cannot do or something they do by default, not helping my purpose of keeping track of. So your keyword here is the profit and expense. That's why I told you, data science always need to find a keyword. What are you looking at, right? How can you tell the story? That's the keyword will tell you that, okay? Keyword will tell you that. Okay, next one, 25. Let me have listen here, okay? And a lot of these you can find out actually the solution, the answer is sort of this one better than the other one. Sometimes it's not absolutely that A should be better than B, okay? Sometimes it's not absolute. So it's actually sometimes personal judgment or experience. But I do suggest you to find a keyword. What's the key point they are looking at, okay? Next one, yeah, okay, on 25.
Is it A?
Yeah, okay, here, keyword is what?
Descriptive of the content of a file.
Static, yeah, so here you actually vocation or computer science or AP concept, the tag tell you that, yes. Okay? Other thing, file size, no, don't tell you. They created, no. Program used to read a file, no. It's actually auto Photoshop, so what? It's actually nothing to define the content of it, okay? Nothing to tell people about the content of it, okay? So number 6, let me have Nico, wait, okay, number 6, 36.
D.
Okay, number 26. Okay, file can be sorted by the date. Okay, metadata improve the actual data. Okay, so here metadata cannot touch the content. Okay, that's the rule. Okay, you don't touch the rule. So file can be sorted by the date created. Yes, when you do that, that will help you, right? The also organization field in the document can be used to keep track of the source of the document. Yes. Who write it? Yes, we know that. Okay. So because we pick A and B, so metadata D will be the answer. Okay. So let's continue to look at C. The length of a set of video can be used to determine. Okay. Yes. You know this file period how long. So when we use try to do playback, we can print it. Yes. So this one is actually D. Okay. Or above. So number 27. Let me have Peter Shen, okay, 27. So why larger data set is harder to keep or maintain the privacy? Peter, hear me?
Yes.
Yes. So is A correct or wrong? A correct or wrong? Large data sets are less secure simply by the size. It's bigger, so it's not secure. A is correct or wrong? Peter, A is correct or wrong? A is wrong. A is secure, bigger or smaller, secure or not secure, you can do encryption. Encryption is by encryption key. So basically, whether it's a big file, small file, larger set, data set, is less secure, it's not true. And secure and privacy are two different things. So here, this one is not related to it, okay? Second one, larger data set have more opportunity for attack because they tend to have more access channel, true or false, 27. B, is it true? Larger data set, more attack. The people might piloting it because there are more channel that you can access it, yes or no?
I think yes.
Yes, this one, yes. Especially when the data is distributed, people will have more way to break the network, okay? Number C, larger data set are bigger set for hackers. So they're more likely to receive attack, more sophisticated attack, okay, than security protocol can handle. So this one C is also correct, okay? Say your IRS database, people try to hack it because they want just to what? Just try to clean their tax record, right? Maybe. But if you have a small grocery stores data, nobody care, right? So basically, B, C is easier to become a target for hackers. Yes. State farms data, insurance data, people have more interest to hack it. Yes. Okay. Citibank's data, people have more interest to hack it. Yes. Than my home account, right? Okay, so C is also correct. D, larger set are easier for safe to navigate. No, this basically because depend on a security measure. Okay, so D is wrong. Is that okay? Is that okay so far for this problem?
Mm-hmm.
Okay. 28. 28, okay, 28. 28, let me have Sunny, okay, Sunny Yen, 28. Why important that online systems larger data set should be scalable? Scalable means that when you the workload or data bigger, okay, the system's performance will be managed, right? So which one is the answer?
B.
Now the answer 28 is A. The 28, the answer is A. Why A? You have system, okay. Let's assume that we handle 1% to 1 million insurance data. So the performance per person should drop. Okay, that means that the response time for more person should be grow not linearly, but actually it should be greater than the linear. But if it actually exponential growth, that's no good. Okay, so we try to keep it as close as the linear curve, but it will not be on the linear curve. Not to mention that the resulting increase in performance is totally impossible. You cannot make a data set bigger and then you performance increase. So if a system is scalable, the future program run faster? No. When your system is scalable, you add more data, it will be slower, but will not be super slow. So the resulting decrease in performance can be mitigated. That's the answer. Is that okay? You would drop.
Yeah.
You would drop, but not drop into the way that you don't like to use it. You know what I'm saying? That's called scalability. It doesn't mean that your performance will increase. That's impossible. You have 2 people's data and 2 million people's data. Of course, 2 million people's data's online system would be slower, but within the certain range that you can tolerate. That's the key point. Is that okay? Does that make sense?
Yeah.
Okay, number 29, let me have Tao Lu Yu, okay? 29. Because all these are related to data set, I'm trying to work on this, okay?
Compression.
Yes. Here you already isolated the keyword for you, so it's a compression right away. You can pick it right away. Okay, 30 for Trista, okay, Trista Jin, okay. Lossy. Lossy actually what you give up, what you trade off.
Is it C?
Yes, we talk about DCT, okay. We throw away some bits. Yes, it's C. Number 31, okay. Number 31, Victoria Ryan.
Is it encryption A?
Personal data encryption, yes, 31 keywords encryption, okay. Okay, 32 is kind of binary conversion. We talked about it before, so today we just it is bypass all of that, okay. Number B, programming, we bypass all of that. Let me see. So this one, okay, 59 may be interesting. Go back to Alex, 59. P2 problem. So you have an integer, right? Your integer. So your integer are 4 byte. Your integer in the data type 4 byte, and you are from -2 to the power 31 to 2 to the power 31 minus 1. And this one is this value. Okay. Okay, so here actually the question is, given the number can be infinite size, why the limitation? Why you want to limit it to only 4 bytes and not 400 bytes, not 4,000 bytes, not infinite number of bytes?
B and C.
Okay, A programmable number to be as small as possible because the limit overflow. You want it to be as small as possible. Okay, that actually is correct, but here we are talking about B number, right? So it has nothing to do with this, right? It's a small, so I don't see it. Okay, here we are talking about integer. B most computing number, okay, within the range. So it's a reasonable size. Yes, B is correct. C making a very large, almost infinite number would require much space that it would be impractical. Yes, it would be impractical. So C correct. No programmer ever need. Yes, there are some people would need it. So D is wrong. Okay. It doesn't mean that nobody need it. Okay. So number 60, let me have Emma, please. Emma.
Number 60A.
Why is A?
Because you can they can have the properties and be separate, so you don't need to put as much code, I guess.
Okay. So programming writing for an architect to create a program describing several property given name, area, and image. Okay, assuming the properties behave in identical format. Okay, what would be the benefit of creating abstract that use these 3 parameters? So abstract is like you have name, area, and image. So let's assume that you create a function, and the function can provide name, area, and image, and you can generate some work. Okay, so basically we need this abstraction so that you can handle it easier. Okay, you can handle it easier. So basically, probably without. So you can recall a function. Is that okay? Is that okay?
Yeah.
You can create a function and you can do it many times. That's the purpose. B, the abstraction will be able to account for difference. No. Sometimes you parameterize, but some available you want to change it, it may not be changed. Okay, so B is wrong. And C, abstraction will make them harder to include in the code. No, maybe not. Okay. D, the use of abstraction would ensure each object file be edited. No. Okay. So D is wrong. Okay. 61. Well, 61 is a trivial problem. Here I have another code. B actually this is too difficult. Nobody can know it. Okay. No one can read the binary and know which line is wrong. Okay. 62 is for compression. Okay. This one, let me have Catherine Lee, please. 62. Which one has higher compression ratio? Why is that?
Because I guess it's like the shortest. I don't know.
No. Compression ratio doesn't compare the shortest. Compression ratio is the original file size minus the total compression, final compression file size divided by the original file size. So you compress the most. So here what? The message with the most repeated pattern. The message with the most repeated pattern. Is that okay?
Yeah.
The message with the most repeated pattern should be P. Okay. 62 too easy. Okay. 63 high level language. Okay. No. 65 you just follow the drawing. Okay. Okay. I think about data is about it. Okay. We are 12 o'clock already. Any questions so far today? I try to pick the kind of information problem related to lecture 3, okay, today. So, any question today? Right now? Any question about homework? Or any other question regarding the AP concept principle? No? No question? Okay, no question, that's it for today, okay? Is that okay? See you next week. But remember to submit more of the exams, okay? Right now, still not too many people submitted this week, okay? Still not too many. You submit more and we will pay more, you will improve, okay? Not too many people submitted, okay? Try to finish it using the weekend, okay? Don't wait until next week to work on it. Weekday, usually you are busy, so you cannot work on it. So we finish the next week 2. So next week will be week 3. Please work on it just over the weekend. Finish them, okay? Usually when go to Thursday or Friday, I don't think you have time to work on them, okay? I don't think you will have time, okay? Any question? Okay, now that's it for today. Okay, thank you. Bye-bye. Bye-bye.